So we are up to number 16. Number 16 involves 8 pairs of socks. They gave you slightly different numbers than the one in the book I'm using, but we're changing it to 8 pairs of socks, all of which are different, I'm assuming in color. These 8 pairs of socks are in a basket of some kind. They are separated, so they're not tucked together, so it's just 16 individual socks. I wrote them as if they are pairs, AA, BB, CC, etc., out to HH. Total of 8 different, I'm referring to the A, B, C, the letters as being the color. So 8 different colors, 16 grand total socks, all individual in a basket. We reach in, we draw out 7 socks, and they are all different. So if I have a sock A in the ones that I've drawn, then I can't select a sock A later on. It's got to be all different. So I'm just going to say the socks that we select are socks A through G, one of each. When they give you a small enough set of things, like here's 16 that I can represent by just letters, if you can write them all out and just know what you're dealing with, a lot of times it helps to simplify the math on these so they get complicated. If I have a large set and there's hundreds of socks, I'd still probably start by doing, 4 or 5 pairs and see what happens. And once I get the math worked out for 4 or 5 pairs, then I can apply that same math to 100 different socks. Don't be afraid to simplify the process by giving yourself a smaller data set, a smaller, simpler numbers, and what works for the small, simple numbers will work for the great big hard ones as well. Anyway, if we've chosen these 7 socks, means there are 9 remaining. Those remaining socks would be the unpaired A, B, C, D, E, F, G, as well as the pair of H's. So this is what remains. When we're doing this, we're doing a probability. They ask for the probability that the next sock that we draw does not match any of these. It's completely different. So when you do a probability, you always want to keep in mind they are always fractions. And you kind of want to draw a distinction between what you're doing and what you're trying to do. And sometimes that's tough for students because they look at a question like this, and when I ask what are they doing, they'll tell me I'm drawing a sock that's different from these. But you're not. You're not reaching in and pulling out a sock that's different. You're reaching in and pulling out a sock. The question is that sock different? If you're watching somebody do this from across the room and you haven't spoken to them and you don't know what their goal is, all you're going to see is them reaching into the basket and pulling out a sock. So that's what you're actually doing in this. So a number of ways of doing what you're doing. I'm going to abbreviate that. Number of ways, I'm just going to put ... This could also be referred to as the number of elements, number of events in a sample space. The number of events in our sample space, if I wrote out the sample space for drawing a sock, I'd have these in them with set notation. There'd be 9 things. This bottom's going to be 9 because there's 9 ways of reaching into the basket and removing a sock at this stage because I have 9 individual socks. Top is the number of ways of doing what you are trying to do. Or concerned with. Maybe you're trying to not do it. They can ask a question for what's the probability that you do not do something. So whatever it is that you're trying to do or concerned with, what they're asking for the probability of, in this case, probability of drawing the next sock such that it's different from these. If I can't pick an A through G, it means my next sock has to be one of those 2. So how many ways can I draw a sock that does not match the ones that I've already drawn? 2. Either that H or that H. How many total ways can I draw a sock? 9. And that would be the probability that your next sock, randomly chosen, would be different than the ones you already chose. That was question number 16.